Welcome back to another video lesson. This is lesson 8.3, where we're going to really combine 8.1 and 8.2 and talk about equations as well as functions and tables. So you are going to need to fill out your table of contents. On page 82, you're going to take your yellow note sheet, just fold it in half like a book, and you're going to put it in your notebook just like the other two. It's another book for chapter 8, and you'll be ready to go. So we saw this a little bit in our work with functions on the first video of chapter 8. We're going to be dealing with functions where we're going to graph them and see that they are a straight line. A special vocabulary word to talk about when functions are a straight line is, we call them linear functions. Linear means a straight line. When we're graphing today, we're going to see points and they should be in a straight line. It's a linear function. The next thing I want you to really wrap your head around is that we're going to link functions with equations. So it's the stuff that we've done in chapter 7 as well. We can use an equation, so I put an equal sign above the word equation to represent functions. That's the new piece today. We're going to draw on what we know about function tables. So we are going to be using tables today. It'll help us show what's happening visually in a picture. So we're going to do 3 things today. Here are the goals. We're going to practice writing functions as equations. We're going to practice writing our own function tables. And then we're going to practice graphing the linear function that should be a straight line. Go ahead and put a personal goal that you have somewhere on this page before we move on. On the bottom of the front cover, we have an example of what we're going to be doing towards the end of the video. We're going to be creating an equation that is already given to us right here. We're going to be making a table that looks a lot like this. And then we're going to be plotting points on a graph, and they should be all connected in a straight line. So now we're on the inside, right up on the left-hand side, first box. We're going to practice writing functions as equations. So here we have tables like you've seen before. We're going to see some of them horizontally, but I'm going to want you to turn the table so that it is a vertical table to help us figure out the rule or the pattern. That's the first thing we have to do. We're asked to find an equation for a function. We have to come up with that pattern or that rule, which is what we did in 8.2. So I'm going to put my input, which is my x value, in a vertical chart. So I'm just going to do our numbers down this way. Then I'm going to leave a middle space. This is where my rule is going to go. I'm just going to label it my rule. And then my output, or my y, is going to go on the right. Do your best to line it up. I know you don't have actual grid lines, but that's okay. If it makes you feel better and you want to do this, that's fine as well. I'm not going to. Once you have your table set up like this, now you have to start thinking about what's the rule. So we're going to practice our arithmetic and geometric sequences. So how can I go from 1 to 16? Well, I can do 2 things. I can either add 15 or I can multiply by 16. So let's test those out. If I add 15 to 2, do I get 32? No, I don't. So let's try the geometric sequence. What happens when I multiply by 16? So we're going to test this out. If I take my 2 and multiply it by 16, will I get 32? Yes, I will. So I have found my pattern. I'm multiplying whatever the x is by 16. So I'm going to fill in all of this pattern to check and make sure it stays true for the rest of the table. 16 times 3, 48. 16 times 4 is 64. And 16 times 5 is 80. So we've found our pattern. Our rule is that we're going to take 16 and we're going to multiply it by whatever the number x is. Our last job is to turn this into an equation. So like we've learned, an equation is that something equals another. We have 2 different variables now. And we're going to need to always write our equation so that our output is our answer, and then our equation is how are we going to get that answer 16 by using x and whatever x is. So the output is going to be the start of our equation. So y is going to equal something. Y is going to equal 16 if we take the rule and apply our pluck and plop with whatever x is. So we're going to put our rule on the other side of the equal sign, which will then, when we pluck and plop 1 in, it will equal what we get on the y column. When we plug 2 in to this pattern, we get y, which is 32. So it's a way of simplifying this whole thing. We can pick x, whatever number we want. 1, 2, 3, 4, 5, 56, doesn't matter. If we plug in x here and then multiply by 16, we're going to get the corresponding y value that will be in this table. So here's our first equation. And they will always typically be that y equals something. Now let's do this one. I want you to try to set it up on your own and figure out what the pattern is, and then try to write your equation, and then I'll come back and show you my table. So here I have my table all turned with a space in the middle for my rule. And now I'm looking at the 1 and the 9. I have 2 different options. I can either add 8 or multiply by 9 to get from 1 to 9. Let's test it out with 2. 2 plus 8 is not 8. So I'm going to have to go back up and say we're going to be multiplying our x by 9, and that will work all the way down. So I'm going to plug that in just to mentally double check my math. 9 times 5, it is 45. So my rule is going to be whatever x is, I'm going to be multiplying it by 9. Our equation, we're going to start with our output, our y equals, and then we're going to stick our rule on the other side of that equation. So we have y equals 9x. Go ahead and put your favorite letter at the top of this page. Whatever letter is your favorite. I would pick A. The next part below is 2 examples where we're given the equation already. We don't have to come up with it, but we have to make a table and graph. Our table is going to have 4 columns when we're actually asked to graph. I know my other ones only had 3, but our first column is always going to be the input, which is the x. Our second column is always going to be the rule, which is going to be the x plus 1. Whatever the equation says y is equal to, that's going to be the rule. Then we have our y column, which is our output. Just going to write that above. And then our last column, just like in our first video, we have to have a list of our ordered pairs. We get those from the x column and the y column. Now we have our table set up. We can pick whatever numbers we want for this problem. Looking at our graph though, I'm not going to pick a large number because I don't have enough space to graph that on the one that I've been given. So I'm going to start and do 1, 2, and 3. It's a good idea to have at least 3 points if you can, 2 minimally to make a line from, but I'm going to do 1, 2, and 3. You could start with 0 as well, that's an option. Let's do 1. In the middle, we're going to pluck and plop, just like we did before, and then you get your y output. Now you're going to take your 1 and your 2 and you're going to actually list them as an ordered pair. So all I did is I took the 1 and the 2 and stuck them together in an ordered pair. Now we'll move on to the 2. If x is 2, we're going to add 1 again, and our ordered pair is going to be 2, 3. And when we add 1 to 3, we get 4. So that means our ordered pair is 3, 4. So this is the table you need to make. Hopefully you have enough room on the right-hand side, just like I have here. And then the last thing is we're going to take these points and we're going to plot them. So the first point is 1, 2, then 2, 3, and 3, 4. We see now, you should use a straight edge. You could use a piece of paper or a ruler if you don't have one. Anything straight, a box, you can use to connect those lines together. You only have to connect the dots that you have. You don't have to extend it down to 0, 1, even though that would have been the point if we had picked 0, and we could have picked 4 and gotten 4, 5. That is okay. We only picked 3. We have our line and we're done. You go ahead and try the second one on the bottom. Be careful of the points that you pick because the graph, again, is kind of small. So here my rule is 3x plus 2. Where did that come from? It came from this equation. I'm going to pick 0, 1, and 2 because I only have a grid that's going up to 5. This one might not even work, but we have to pluck and plop. 3 times 0 plus 2 is 2, and then our first point should have been 0, 2. When we pluck and plop the 1, we get 5, so that's 1, 5. And when we pluck and plop the 2, we do get 8. And right away I'm noticing, oh, I'm not going to be able to graph this one because of the limitations of it only being up till 5. So let's graph what we can. We have 0, 2. Again, we really only need 2 points to make a line, straight line. If we had a bigger graph paper, we could have plotted the third one, but this is okay. It's a very steep line, and all we need to do is connect the 2 of them like that. One more thing to do. So the last part of this video is on the right-hand side of your book. We're going to go backwards. We're going to be given a graph and asked to make a table and come up with an equation. So what we have here is heights of cactus growing over the span of 3 years, and we have points on a line. We're going to use these points to help us make our table. And the table is going to be the same setup as before, with the input, which is our x, our rule, which we don't know what it is yet, our output, and then our ordered pairs. We're going to start over here because we're going to look at this dot and figure out, okay, what's the x and what's the y? And the first one is at 1, 42. The second dot is at 2, 44. And the third one is at 3, 46. So we can go ahead and fill in, whoops, here's our y, our x column and our y column. So we have a 1, 2, and a 3, and we have a 42, a 44, and a 46. Now we have to go back and find the rule, find the pattern. So we have done this in 8.2. Going from 1 to 42, we have 2 options. We can either add 41 or multiply by 42. I'm going to try both with this second pair of numbers, 2 and 44. So if I add 41, I get 43. Now let's try multiplying it by 42. Is that going to be 44? No, it's going to be much higher. So this is the case where you're going to need a combination of multiplication and addition. So let's look at this pattern going down here. What do you notice that's going on the same from 42 to 44 and 44 to 46? I'm seeing that it's increasing every time by 2. Remember from our video last time, this means we're going to have to multiply our x by 2. So the fact that this is increasing by 2's, you're going to have to double the x first. So that's part of our pattern. If I were to double 1, I would get 2. What would I need to add to 2 to get to 42? I would need to add 40. Let's try that to see if it works for the second x. If x is 2 now, I get 2 times 2, which is 4. If I add 40, aha, I get 44. So now let's test out this pattern here. Seems like I have to add 40 each time, and it works. 6 is 2 times 3, and then when I add 40, I get 46. So my pattern is 2x plus 40. The last thing I have to do is write the equation. Just like before, in the beginning of this video, we start out with the y equals, and then whatever this pattern is, that's the other side of the equation. Y equals 2x plus 40. You have one more to try on your own below. Make sure you do that. I'm not going to go over that, and that's going to be your test to see how you are going to be applying what I did here for one on your own. We're going to do this the entire class tomorrow, and I look forward to seeing you then.